Hello. So when Nadia sets up, we'll say welcome to this fantastic talk that had about 3 different titles. We called it Demystifying MLOps, but it could have been called Demystifying MLOps. And it could have been called, here, look at my Bitmojis, they're cool. So luckily, we went for Demystifying MLOps. So I'm Derek Bingham, a developer advocate at AWS.
Hi, and I'm Nadia. I'm a DevOps engineer at Mechanical Rack. Super excited to be here and co-presenting with Derek.
So as Ben articulately put, I will be doing the intro. So let's start with a level set. MLOps. So as you can see in this Bitmoji, I am calm, I am centered, because I've automated everything. And much like its cousin DevOps, MLOps is all about automating everything. You may automate different things than you would in a development pipeline, but with MLOps, you automate things like training your model, deploying that model, and then other bits along the pipeline, which and Nadia will explain as well as we go through it. So when you think about MLOps, just think about automating everything. So to start with, I'm going to start with some foundational components. So I'll talk about those before Nadia goes into implementation details and the services that you would use to build an MLOps pipeline. So if you want to create your perfect ramen and have it filled with the best MLOps ingredients, these are what you would think about. If you have a look at the QR code, there's a lot of detail to the article on the QR code. It's not a fish. It is a real article written by Nadia, so that's well worth looking at to go into more depth in what I'm about to speak about. So first of all, obviously security is the most important top-of-mind thing that we think about these days. And this is actually a picture of me going through an airport, not a Bitmoji, actually me. And security and monitoring, when you think about MLOps, is how do you lock down your pipelines to the people that should see them and nobody else? How do you reduce access from the internet? So you want to lock down any public access. You also want to think about how you're going to encrypt your data. Exactly. How you want to encrypt it in flight and at rest. So as a budding security architect, on the knee of a security architect. So that's meta. So those things you want to think about from a security standpoint. And obviously monitoring. So we're all about observability and monitoring. No difference when you think about MLOps. So you want to monitor how your model is behaving in production to give you the power to then go, well, is there bias here? Or is this the wrong model in production? Monitor that and then feed that back into the start of your pipeline that you can then change and deploy automatically that model. So when we start thinking about a pipeline, the first thing we need to do in MLOps is obviously initial data investigation and exploration. Now, this can typically take the form of running a whole bunch of theories against different data sets, different training data sets, and coming up with some outcomes. You can do that, but when you're thinking about MLOps, you want to make those experiments, you want to make them traceable, so you have a record of what you've actually done. Otherwise, you're wasting your time. So think about that when you think about starting your MLOps journey. So once you've thought about that, the next thing is building that pipeline. So building the start of that automate everything journey, and you do that using the ML pipeline, where you build, train, and deploy that model into production. So the steps of an ML pipeline can look like this. There'll be 3 steps. And the key step is a model registry. So I'm looking at the model registry because that's a way of decoupling what is to the left, which is where you train on different data sets, train different theories, and so you can do that separately before you deploy a version of the model into the model registry. The model registry is basically taking and storing different versions of the model. So you do that first. You train the model, and that can do one-to-many iterations, deploy one-to-many model versions in your registry, and then the final step is actually the deployment of that model. So that decoupling is a nice way of splitting up your MLOps pipeline. And then this slide, and I think this is my last slide, is continuous integration and continuous deployment. It could have been called CI/CD, but that's boring. Continuous is spelt wrong.
You didn't pick it before.
That's why everybody writes CI/CD. It's continuous is a challenge. So much like DevOps, this is core to your pipeline. So continuous integration is where you make code changes and you continuously make those code changes and commit them and push them to main or a branch, like build, and then the continuous deployment, which is completely different, is where you take a version and you deploy it into production when a new version arises. So that is the automation part, no different in MLOps. Just think of what precedes it and how you put it together. So enough of boring old Derek talking and having misspelled slides. I'd like to now pass on to Nadia. One thing that Ben didn't mention is Nadia has been known to drink directly from the oat milk in the office. So that's another, just some information about Nadia. So Nadia will now go into how to actually build those things I've talked about on AWS and the options that you have. Nadia.
Thank you, thanks. Yes, machine learning has been a very trendy topic. How many times we heard OpenAI, generative AI, LLM, so it's over the place. But AWS has made machine learning accessible to everyone. Data scientists, machine learning engineers, simply with providing ready-to-use AI services such as recognition, Poly, Deep Racer that is running next door, and so many other services that we cannot list them all. As well as fully managed services such as Amazon SageMaker that has been designed fully for machine learning. With the next few slides, I'm going to walk you through some of the options that we have to orchestrate our machine learning solutions on AWS. Within the slides, we have QR codes. They are not fake. They will actually direct you to the workshops or the GitHub repositories with the examples. Let's start with the first option. Yes, Amazon Code Pipeline. We all know that one as a CI/CD tool for DevOps engineers. But interestingly, AWS promoted this for orchestrating machine learning workflows as well, so that you can tie up and add every single of your part of your pipeline as a code build job. You can set up your pipeline to be triggered with an event whenever you have a new data set is available in your source bucket, or you can watch out for any changes that is merged to your GitHub repository or your code commit. Knowing that how a service or tool works helps us a lot to understand if that solution is a good approach for our use case. So let's discover some of those features for Code Pipeline. First of all, Code Pipeline is a very general CI/CD tool. It's not tailored for machine learning. But if you add all those operational tasks as a code build job and just manage your building, testing, and packaging within your code pipeline, is a still efficient tool. And you can just put all of your workload for machine learning to other tools such as SageMaker or AWS Step Function that we are going to discover soon. But because it's not tailored for machine learning, it comes with some restrictions. First of all, we have a hard quota for code build because we run all of our tasks as a code build job. We have an 8 hours. If you're training your model for more than 8 hours, you will get a timeout exception. Another restriction is the size limit that you have with code pipeline artifact. At most, we will get 5 gigabytes. So if you are transforming your data and you want to keep that one as a code artifact, code pipeline artifact, you will be in trouble. You have to manage that one in a way. Every simplicity comes with a price. Yes, code pipeline is so easy to implement. You can just create a pipeline in less than an hour. But for machine learning, parallelization and concurrency patterns are really limited in code pipelines. Yes, you can run multiple code build jobs in parallel, but if you want to execute your pipeline with multiple parameters to train different models, you need to consider that one, that it stays in an internal queue and it will process each request after each other. So it will be time consuming for your process. However, code pipeline is still a CI/CD tool. So one of the things that we discuss is that we need to have decouple and like isolation for every stage of our pipeline. And code pipeline with the retry allows us to have that implementation. So that if for any reason your training model failed, you don't need to run all the data processing job again. You can just rerun your failed job, which is probably training. This brings us to the second option, which is my favorite one as a DevOps engineer, AWS step function workflows. AWS step functions, they are like state machines. They start with an initial state. You can transit from one state to another state with running a Lambda function, or you're having a nested step functions. They are serverless, so it's cheap. You can save cost, but as Peter mentioned, probably not the approach for everyone. They give us a really complex parallelization pattern. Because of the choices that we have, we can just branch out from one from the other step. Such as this example that we have here, you can have the main step of your step function as the main skeleton, and then have the nested step function for other stages. For instance, if you're running a training, you can have the training as a nested step function and go through that one. In here, we could like even go further down and have the data processing as a separate step function. This allows you to have decouple implementation. If your data processing again fails, you don't need to run the whole workflow. You can just run that step function. But what has made the step function very popular? First of all, because they are serverless, you can have high performance at lower cost solutions. If you were processing your data stream and you want to save that one in S3 bucket or your DynamoDB table, you can easily implement that one with a step function. Step functions, because of that branching, looping, and parallel and map kind of task, it gives you more complex in parallelization patterns. AWS Step Functions Workflow Studio allows you to design and orchestrate your step function without even writing one line of code. You can just simply go there and just do the drag and drop and orchestrate your, design your orchestration, which makes the building faster. And if you are going to spike on a solution, you're not sure if it's a good approach for you, you can just design it without writing one line of code. AWS Step Functions is a popular tool or service for developers. And Data Scientist SDK also integrates with a step function. So you can easily improve that collaboration between your team. It will improve the learning curve. One of the things that I really liked when I first started using a step function was that freedom that you have to manipulate that data. If you are dealing with a big data, you can just get a small fragment of that one as an input and pass it to the next state. AWS Step Function integrates with a wide range of services on AWS. So you're not just limited to SageMaker. You can just run a glue job within your step function. You can send a message to your SNS or SQS queue. You can query DynamoDB. You can upload a file to S3 bucket, download a file from S3 bucket. So you're not just creating a pipeline. You have more integration with all the services. Let's check out our third option. It's Amazon Managed Workflow for Apache Airflow. Amazon Managed Workflows are a fully managed service for orchestrating Apache Airflows. And Apache Airflow is an open source platform for managing, monitoring, and scheduling workflows and data and computing workflows. You can just plug in all the tasks that you have in machine learning in a workflow and easily run your workflows on AWS. It will completely give you the same UI as Airflows. You don't have the hassle of managing and configuring the resources. It will be fully managed by Amazon managed workflows. Our option is growing. When to use Amazon managed workflow? Oh, I missed it, how it works. So let's check how it works first. So to create the workflows, you can first just import all the libraries that you require for your pipeline. SDK, like the libraries that you use. Airflow, SageMaker API. You can create your DAGs or directed acyclic graphs. That is a way that you configure your operations. Operation is the way that you create and execute your task. You define your task, and after that, you create a dependency between those tasks, which is actually the order of execution of each task within that workflow. And now check when to use the Apache Airflow. First of all, Apache Airflows, they are really extensible. You can create a workflow with a set of tasks like data processing, training your model, deploying your model. And you can use that workflow elsewhere. You can extend that workflow if you decided to have like more complex workflows. And because of that, you have more complex pipelines and designs. So far, we had like a similar solution at a step function. But what has made the Apache Airflow a little bit less popular, maybe, is that the Airflow serverless option is not still a thing. If you have a really heavy ETL jobs that running for a long period of time, you have to consider about the cost because it's not serverless. And Airflow is a Python base, and it will be an easy tool to pick up with data scientists. But how you create those operators, how to create the task, how to define them, it has a learning curve. Whereas we said that a step function, it will improve that collaboration between teams because they already have that knowledge. And the last one, but not least, Amazon SageMaker Pipeline is an AWS-specific CI/CD tool for data scientists and data engineers. You can create the pipeline with Python SDK or your SageMaker API, and you can just visualize that one within your SageMaker Studio. What problem has solved? First of all, it's a CI/CD tool. So it comes with all the specific features that we expect from a CI/CD tool. We can have very complex parallelization. We can execute and schedule our pipeline because it integrates with Amazon Event Bridge. We can even narrow down the rules that we have in every stage of our pipeline and give that a stage only that a specific access that we need for that execute that task within that stage of our pipeline. It integrates with Amazon SageMaker Studio. For those who knows Amazon SageMaker Studio, it's just like one shop for everything. You have feature store that you can just get a database from all the features that you have created for your data set. You have the experiment tracking. You have debugging, monitoring. So it's all the components that Drake just mentioned, entirely everywhere. You can create SageMaker pipeline templates to have a full CI/CD package. We can even cache the pipeline steps. So that means that if you have run the same step with the same parameters in the same pipeline, you don't need to execute that one again. And you have a data lineage tracking integration. That means that you can track your data, where it has been inputted, and where it has been used. And also the local mode enables you to run that locally, test your scripts without using SageMaker service, so it doesn't cost you anything because it's using your compute. That wasn't all that AWS offers for us. If you are using Kubernetes and you want to orchestrate your machine learning solutions on Kubernetes, you have 3 ways. You can install Kubeflow on AWS, you can use the SageMaker components in Kubeflow pipelines, and you can use SageMaker operators for Kubernetes. And that brings us to the end. Yep.
Yes, so that's a lot of information to take in. Thank you very much, Nadia. Lots of QR codes if you're interested in all the services that Nadia has spoken about. They're all there. Talk to us after. Talk to us afterwards for any questions. And we had an absolute pleasure, well, I did anyway, speaking to you all today. Thank you very much.
Thank you.